Hej og velkommen. Er der nogen, der ikke snakker dansk? English? Sure. So hi and welcome. My name is Peter Glenstrup. I'm from Nimble Storage, and today we would like to show you some cool stuff around the vVault and stuff. Before that, I'm going to talk a bit about Nimble Company. Who are we and what do we do? So first off, I would like to introduce my colleague Steven. He's going to do some demo. We're going to jump into some live demo stuff.
Ooh. So
if you can, look past the good old 4G connection you got, it's going to be good.
If it behaves.
Now upgraded to senior system engineer.
So. Way.
So what he's going to help out, we invited Robert to help us out with the vVault stuff. So we're going to do some great stuff for you today. So anybody using vVault today? Testing it? We actually got one of the oldest vVault customers in the Nordic region, a Norwegian customer who's been using vVault for over 2 years now. So they're part of the Norwegian company, company. So we can speak to them, and if you want to talk to one of the old guys that have been using it for many years, then we can do that. Well, let's kick off. I see some Nimble customers. Who else besides the Nimble customers know about Nimble? Yeah. So a short slide. I will try and do it as little marketing as possible. But the company itself actually started back in 2008. So our founding members back in Silicon Valley sat down in a garage or cellar or wherever they coded the stuff. Started saying, we need to do something. This storage industry has been relying on these disk drives for many years now. So how can we do something else? And they started interviewing all these customers around the old OLTP workload, the good old SQL servers, Oracle, and SAP and stuff. And all these customers back in 2008 said, hey, we got this problem, we got a performance problem, capacity problem, whatever problems we actually still have today, they still had that back in 2008. And then they sat down and said, hey, we need to code something here. We need to get the app closer to where the data is. So actually they started out with a product called a flash device, where they had this flash device put into the host server itself, and not that many users or companies use VMware for the high-end workloads. So we actually started out building a code for a flash fundamental flash drive into a host server itself. So, and the way we did that was to say, if we are going to destroy or disrupt the storage world, we are not going to be depending on disk drives anymore. Even though we got great flash drives, and back in 2008, flash drive was a bit expensive, but we needed to do something else. Then they started off with that and said, hey, maybe we should do something else, and then instead of just doing host, because VMware are good partners, alliance partners, they actually came into market and said, hey, we can put on top of our VMware infrastructure great workloads. So we said, okay, if we got a great partner like VMware, we need to do something else. We need to do a storage product, a classic storage product. But our mission was still not being dependent on drives itself. So how can we do that? So that's what we actually did in 2010. We went out to market and said, hey, we got this storage product and we are not depending on disk drives. It was a way different talk to have with customers than saying, hey, whatever questions you had around performance, the answer was always buy more disk, buy more disk, buy more flash drives. I don't know if you have been experienced that in the companies today, but many vendors, storage vendors, say, hey, you need to buy disk drives. Well, if the question was not capacity, I just wanted more IOPS or lower latency, or more throughput. So they looked at 2010 and said, hey, we need to build a storage product, and we need to build it like nobody else. So we went out to the standard x86 market and said, hey, we got these great Intel CPUs, we got something called RAM, and we got something called NVRAMs. And we started building a product to controllers based on CPU and RAM. So every time a host server did a write, 4K, K, whatever size you did on write, it was handled by the system's CPU and RAM, not the disk drives. So we disconnected that. The product we launched in 2010 did that. And we've done great since, so marketing side, over 9,500 customers worldwide. In Denmark we have over 120 customers. great references, you can use them, and some of them are here in the room. So all the funny things I say, you can look at the customers. Kenneth is here. So if I say something wrong, just look at Kenneth and ask him. Yeah. So, and we are, been into Gartner, we've been traded publicly, so you can see all our numbers and stuff. Some of the cool things I think that, besides our great customers, thank you for being there, is our alliance partners. So VMware has been one of the oldest ones, so we are really tightly connected with VMware. We've got great integration, as I'm going to show you today. And others like Veeam and Lenovo, the newest one. I don't know how many Lenovo customers are here in the room using Lenovo servers? Nobody? So we see a lot of those in Denmark. Lenovo servers is great in Denmark. And we're going to do some great stuff about convergence and hyper-convergence on around that product. Other great products like Microsoft, the SQL servers, we are doing great stuff with that, and Oracle. Stephen is going to show you some really cool things about an Oracle DNA. That's quite cool. So we're going to show that live to you today. So what was the problem? So back in 2008, and actually today, all of your users, your customers, and if you're working with IT, your customers is actually expecting you to deliver this. The app they are using, whatever it is, on a mobile device or on the laptop or desktop they want to have great performance, and they want the app to be up all the time. So the business owners, they're called, or whatever, management guys you have running around with great suits on, they expect you to deliver that service. And whenever this happens, so whenever I show this slide, everybody, somebody's sitting there, oh, I don't like this, look at this, loading screen. So we have a lot of things with customers who have, been sitting and waiting, doing queries and whatever database they're using, ERP systems and so on. And if users aren't used to this, well, the productivity in your company is not that great. So I think most of you are trying to solve this. And the way we did it back in 2008 to 2010 was to say, we need to bring these two guys together, the database and the data itself. And we sat down and said, we have two storage controllers, we have picked out these great storage controllers with a huge amount of CPU cores and a lot of RAM and NVRAMs. But is this enough? Is Flat's product back in 2000 enough? It's not bringing the data still behind a fiber channel or iSCSI switch, host server, HBAs and stuff. That's a long way from the app down into VMware virtualization layer, and then finally going down to the storage. So we sat down, and one of our guys, Rob Back, great guy running around in Hawaii shirts, and his team programmed a product called InfoSight. And what InfoSight does is actually using all of the good old sensor data we have been using for many, many years. Big products, management products have been using this for ages. We took those sensor data that all your microcode, all your drivers, all your OSs, all your VMware, whatever apps you have, and whatever you have in between the app and the storage, we collect all this sensor data and we give that back to you. So that's one of the demos we will see. But what it gives us is this slide here. So it gives us the ability to look at our customers and say, hey, the problems, the root cause, and I know this, we do the error finding, whatever you call it. Is it hard or is it easy? It's pretty hard if you've got a complex data center with host servers, network, and storage, and everything in between. So we simplified that in our product InfoSight, and we delivered that back. And what it shows us is actually what our support and our customers, and can maybe order something and say our support is great. So the marketing slide I had before with the NPS score, our customers love us because we get great support back to our customers. And the way we do it is inside of this. So if you can see here that more than 54% of the errors our customers is getting is actually outside of the network. And many storage vendors I've been working with have been using finger pointing, it's Cisco's problem, it's VMware's problem. We don't want to handle that support case. Our support guys is coming in and say, hey, your Cisco Nexus switches are implemented the wrong way. That's a cool input to get. Should I fix it? So our support guys is logging into a WebEx and say, I'm logging into the Nexus GUI and fixes this problem. That's why our customers will love our support. It goes up to the SQL always on feature and fixes SQL problems. It goes into VMware and say, you've got misaligned I/O, so let's fix it. And if we can prove that more than half of the errors you have out there in the data center is actually not the storage guys, then we can fix a lot of issues. And then we can bring the app closer to base, because we can fix your ACL problem where you're not following best practices. And you didn't download the correct driver on that HBA, and all these really complex things. We will find them automatically for you and send you the fix for that.
We can blame the network guy.
So we deliver a product, and we deliver an all-flash storage product. It's our foundation. And we deliver a hybrid flash product. We can connect them together, and we'll get back to that. And we deliver our InfoSight. So we got a Nimble OS and we got InfoSight. These are these two really great golden nuggets we have. This is Nimble. So, and they deliver a really fast environment, reliable and predictable, and really, really simple. So many customers in Denmark actually tells us, hey, the greatest thing about Nimble was we don't have it on our Monday morning IT staff meeting. We don't have storage as a point on our agenda meeting. Beforehand, when we had another traditional storage vendor, well, we had something around licenses. We needed to buy this price because the vendor told us to buy this price because we need more IOPS, and so on. Nimble removed that totally. So it's really, really simple. So, enough about the marketing stuff. So take how did we build this product? How can we do this? In other businesses, flatlines are good, but we deliver a flatline product. We always deliver the same amount of IOPS, the same low latency, the same throughput as you got from day zero of the product. So how did we do this? It's actually a totally standard product we found out of the market and said, hey, we built a great CPU, and then we use this NVRAM. And NVRAM is a special thing. Standard again, it's been at market for many years now. Nobody's actually using it. I haven't seen other vendors doing the same thing as we do with the writes. So whenever a write comes in, it comes into this NVRAM stuff. And NVRAM is a DIMM card, is a RAM card with two cables out of it. And you got a supercapacitor, a battery, who holds 200 seconds of life in these RAMs. So now you've got a non-volatile area just sitting beside of the CPU with 4 memory lanes into the CPU. So we've got it's the fastest possible area we can buy to. I know the future will come with other stuff, but we are really quick. Our Nimble OS can do whatever we want with hardware. So we can bring whatever cool stuff comes into the future into this product. But right now we have this NVRAM, and we put all your writes in it. And look at the 8K, 4K, 4K, 8K, whatever K write size you have. We don't do anything with that. We don't do a split up to 8Ks, suddenly 4Ks, and do cycles, CPU cycles for that. We just store the Ks or the writes into this NVRAM space we have. Then we wait, because we have 200 seconds. If something catastrophic like power failure is going on now, we have 200 seconds of power. We can use these 200 seconds to destage this to a flash model, who's on the motherboard. So this flash model will hold the data to whenever the power is back on. Whenever the power is back on, we're going to stage it up to NVRAM again, and then do this full stride. So we wait, we don't have any hole fillings, we do a full big, really, really big write, and we sequentialize it and write it down to the drives. And remember the SQL app who just did the 8K write, he got response time many milliseconds or microseconds ago. So we are not depending on, we use the slowest, biggest NL SAS drive out of the market and still get predictable IOPS and throughput and latency. And what we found out back in the good old days of 2010 was, hey, we got this great knowledge about compression and deduplication. So couldn't we do something with this right? If we know all of the layout on disk drives, we can actually say, hey, why not say, if I wrote this block of 8K I don't write it again. So we did a lot of cool stuff inline before it hit the drive. We're gonna do effectiveness of deduplication and compression of this data and use this drive itself as much as we can. So this is really cool. So and what we also found out was the thing about support. We got a flatline support. We don't charge whenever you go to 3 years, 5 years. It's still the same as the first year support. But the way we also thought about this little feature here, if we can extend the SSD as a storage vendor, the failing of drives is fairly costly for us. So if we provide a 5-year support agreement with you, and something goes wrong with the drives, we need to pay that drive because we need to go out within 4 hours and change that drive. What we found out with this layout was we could extend the way we do the layout on drives. I'm not going to cover that today. But we found out that something called garbage collection or services are not that hard because we control the layout of the drive really, really nicely. So we could do 7 years of hardware support on this without us costing anything, because we know the drive will not fail that much as if you did a random write on these flash drives. Does it make sense? I'm not going to cover that once again. And then we got something called reads. So in an OLTP workload, it's a random read write load. And whenever we do a read, we actually, before we write it down to the lowest in the SAS drives, the slowest drive, we actually do a copy of the layout into SSD drives. And it's not a tiering model, it's just a copy of the data. So whenever the SQL app, now it's written an 8K drive or 8K write, now it's going to ask for the same or different 8K write from read. It's going to be hosted from Flash. So this is our hybrid array. This is the thing we did back in 2010. And the market reacted with, we've got a lot of customers. So it works and great product and stable flatline. So the market went into I don't know price-wise, but the market went into a thing where flash drives were a bit more cheap. So we went into this market and we did the exact same thing. Still have vRealize, it's still much faster than a flash drive, the fastest flash drive out there. So before we are hitting the flash drive with a nicely laid out sequential write on flash, we still use vRealize. The only difference between these two systems is the way we do reads. So now we do host read from the SSD drive. So we get a potential bump. Something is not written within 2 months or half a year or something. We need to state, and we have great algorithms to handle this. And we get a bump for 0.240 milliseconds on the hybrid array, and we then don't get a bump on the all flash. So the all flash deliver 1 millisecond of latency all the time, flatline all the time. The stuff on the left is delivering under 2 milliseconds all the time. So that's the difference. Price-wise, we still got a price difference between these two. That was a bit technical. Is that okay? Level price? So reads, great reads. This is the product, great 4U unit. Our biggest solution delivering 8.2 petabytes of data is same size as the smallest one. Why we built this was to have the scalability of controller. So we are going to scale in a different way. I'm coming back to this, but we have the same form factor. So our controllers is these two, and we have an active-passive controller. The reason we did that was to control the workload. So if you have an active-active Lua system or any active-active system out there, and you don't have a reasonably simple way of controlling the load of these two controllers, the ideal way would be to have 50% of controller A and B. But if you turn on services like thing we just do inline, like compression or snapshot, whatever, you can actually see some systems going 75-50. And whenever you do a firmware upgrade on those systems or do something with the controllers, 50 plus 75 is more than 100%. Something happens. So I love the simple implementation. We will never ever do active-active because of this. we can do great software to control this active stuff, but it's complex software things. Why not just use a simple implementation like active passive? Say one controller can only do 100%, that's it. Then just use big CPU and many RAMs to handle this. We've got PCIe slots, we can scale this, 5% large clusters, whatever you need, 5 channel Ethernet. This is the product line. So look at, I don't know if you are running tenders or part of it, like home, but 35,000 items on the AF1000. The CS1000, same amount of items. We are not depending in any way on the RFQ price. So when I'm meeting customers and designing this stuff, I'm always saying if you're buying this year full of SSD drives, you will never ever get more items. That's a different way of designing the stuff. But if we are going to promise you a flatline system forever, we cannot be dependent on SSD drives or whatever drives out there. And we can take the controllers out of the back. It's all for you, same form factor. The only difference is the bigger CPUs and amount of RAM, the bigger the system is. So we actually have, how many Danish customers have done that? 2 customers?
Hot swap?
Forza did it themselves.
Yeah.
So Dana, he got 2 new controllers. He wanted to go from a 5 to a 7. He got it. Normally we want to be there to help our support will be online. Did he do it himself? No. Try to go from a 5 to 7. So Dana here did it. He got 2 controllers. This is a pretty hefty thing to do online in working hours. He did it at 9 o'clock. Got these 2 controllers. Normally Forza is a pretty big customer. They've got over 600 SQL servers, so they're pretty big. Took one of the controllers out, set them at 9:15, and put a new one in, swapped the workload over, and took the old one and put a new in. Within half an hour, he swapped the controllers himself. That's how easy this thing is. And he just went from 120K to the bigger one. Because he needed CPUs on hand. He didn't need capacity, he needed more performance. So the way we scale is the way you need to scale. And our product, our emphasize that we're going to show in 5 minutes, are actually coming out and telling you what you need. So all the sales get work is not part of our product. The product itself will come out and say, hey, you need more CPUs, go from 5 to 7. Here is the Dana customer. If you need more capacity, you buy more disk shelf. And if you want to do something really enterprise-wide and scale this system out to 8 controllers, you can do that. So if you want to go really big, you can do a really big solution. Main ports, great throughput and stuff like that. Or buy whatever you need and let the system come out itself and say, hey, you need this to handle this workload. And we actually got tools to predict whatever workload you have coming in. So for service providers or big customers, you're saying, oh, we need a new SQL workload. Put it into the InfoSight system and say, how can this workload be done on my system? And it will show you what you need, and if you don't need anything, just go ahead and deploy this. Same way with our CS hybrid system, same story, no limitation whatsoever. The second thing is, what we did was to look at the apps. So this is normal apps, SQL, Oracle, WhatsApp, and so on. And what we tried to do was, hey, all these workloads need different things. So many workloads need some scalability or simplicity or whatever they are needing. So if we are looking at these apps, when Oracle, for example, are any of you running Oracle? Oracle DBAs? Nobody's. Yeah. So this workload needed. Let's do a check mark thing. So if you're sitting back home designing storage, so we have a policy-based storage system. So we do Oracle storage for the Oracle VM. We do SQL storage for the SQL VM. We're going to show that to you. So this guy here, I want guaranteed latency under 1 millisecond all the time, every time, flatline. I want some compression because I love compression. All the databases are really good doing compression on it. I want some encryption because it's highly, secure data or something. By the way, you can do deduplication on encrypted data, and we do it per volume. So we don't do it per array. So you can actually remove encrypted volume without destroying the whole array. So it's a cool feature. But this guy needs it. It needs a backup and a data protection where we replicate the backup over to a different site. So this guy needs to go to all flash. Perfect. We've got an all flash solution for that. Next guy here, SAP, he needs some compression, deduplication, but he can live here on the CS platform. So now we've got two workloads with two kinds of, workloads checkbox list on it. Wouldn't it be cool to do a scale out with mixing these two product lines? So we did that back in the 2010 as well. Said, hey, let's do a scale out with the oldest or the slowest system and the newest or the fastest, and just mix them in a group. So we can do a scale out mixing these two products we got, or the oldest one 2 years ago with the newest one, and do online movement of the workload. So imagine the old workload doesn't need a 1 millisecond response time. Well, we can move that SAP test and development, just move it online without the app ever knowing about it. These 4 controllers up here are the same storage system. We've got multi-part software in front of it, controlling all of this. It's seen as one storage product with 4 storage controllers, mixed between a hybrid and an all-flash. So you can buy the smallest all-flash 6 terabyte solution with a 1 petabyte CS solution, all seen as one. More than you're doing that, right? Have you ever grouped it together?
No, we haven't grouped them.
You're planning to do it?
But you forgot you can do, you can pin.
Yeah,
Sorry,
we have always get pin. So that's an old feature. So what more is on the CS platform, we got a lot of caching, really big caches. And we can do that, say, hey, if you got this 500 gigabyte SQL workload, we can pin that into cache. And say, I don't want to have that bump of 0.24 milliseconds. I want always flash performance. I want a flash experience for that SQL workload. And we can pin that data to always be in flash, whatever the algorithm or our system tells the system to do. These 500 and 100 gigabytes will always be hosted by VMware and the SSD flash in a CS platform. So that's a great feature. Good old one. So, yeah, we can move all these workloads around all the time, and use, I don't know how many of you using quality of service today, but we got something called ARTO on noisy neighbors, full EVMs. We can handle those automatically, so we can move a noisy neighbor away from the system and say, hey, you are in the penalty box, you're not going to destroy the 500 other VMs there. So we are automating a lot of stuff on that. We can set limits, so if you got a limit, I'll say, hey, dear Mr. App, you only can have 10,000 items. It's not a hard-coded, whenever it goes over the 10, you will get a log, email, a system alert, hey, one of your apps is doing this. And you can do a lower limit as well. So if a service provider, for example, or enterprise, you can control these systems. So a lot of cool things. So what we've extended and what we've been working on for many years actually is the integration with VMware vRealize. So vRealize is another, and Robert will come back to this, but good old design. You have some VMware host servers, some great apps, and you have a data store. And if we wanted to do something really simple and getting a more simple way of managing all these VMs, we went into vRealize and we said, hey, why not do a data store per VM? So vRealize is a lot of small data stores. It's a data store per VM. How many of you know vRealize? Look into ask the question, are we using? Last group, yeah. So, as I said before, we are a policy-based storage system, so we provision this stuff automatically, and we are going to show it to you. It's much more fun to do demos than seeing a slide deck. And we're going to do, I don't know, I'm covering snapshots and clones. We're going to do the retention thing, sorry. The backup. You're going to set the backup.
I'm going to show something with the snapshots.
Yeah.
So
So
I have a screenshot of it.
So we got a great snapshot feature, so we can do 150,000 snapshots of these things, and we can clone them. So if your DBA is asking, what is DBA or what a Oracle database dump? Well, it's just a clone. It's not going to be 4 terabyte clone. It's going to fill the metadata we're doing to the pointers of the snapshot. So we can do encryption, as I talked before, and we can dedupe that. That's a great feature as well if you want to save some space. And yeah, we can actually do the replication as well. And we're really proud of it, so I'm not going to use that much time again, but some of the, Duncan Epping is here, right? So actually said, hey, Nimble is one of the greatest. We support VMware 2.0 and Base at 3, so we're really fast on implementing the new stuff.
Duncan says it's cool, it's gotta be cool.
We are working a lot of OpenStack things, so we got the simplifier, so anyone working with OpenStack, you can do that, and the other version of containers, like Docker, we are doing a plugin for that as well. So this is really cool. I think it's a great product, but we wanted to do something else. We wanted to get all this sensor data. We have 8 years of data. We have a big database in the States collecting all of our 10,000 customers' data, and we are analyzing this. So we're doing machine learning, and we're doing a lot of proactive stuff that the customer actually don't see because it's a support experience. So we go out and say, hey, what if we could blacklist customers for doing something bad to the environment? That's a cool feature to have. Hey, I'm trying to download this feature that actually will destroy all my SQL workload. You cannot do it, because we know it will destroy your Cisco Nexus replication thing or whatever you have. That's a cool thing to have, but you don't see it if you don't have a problem. It's a cool thing to know that we're actually stopping you from doing something bad. Some examples here. And we can do whatever we need to see. We can test a lot of stuff. And if a guy back in Singapore has a problem that you will experience if you do something, we will call you up and say, hey, don't download this VM update because it will do something bad. We cannot stop you from downloading Microsoft stuff and VM stuff, but we can stop you from downloading Nimble stuff. But we can call you privately and say, hey, don't upgrade your C6 environment because that will destroy your VMUG. But the support experience some customers have. Some examples here. This is a server vendor. So the customer had, high latency, good old stuff, spiking, high latency. We did an analysis of this and found out it was a NIC card in one of the host servers. I don't know if you have that problem, but it's a fairly hard thing to analyze on. We just went in, it was 3 minutes or so we used on finding this problem and said, hey, host number 4 has a faulty NIC, please call the server vendor this and ask for a new NIC. That's a cool support in the thing. The second thing was VMware, and actually VMware wrote a knowledge article on this. So Nimble was the first and only vendor who found out that there was something on the iSCSI thing. So if you were implemented back in the days in VMware version something, downloaded the iSCSI thing from VMware, you probably hit this. So we had a thing where latency spiked again, and we went into VMware and said, hey guys, you actually did something not that cool for the iSCSI implementation you did. So we actually helped the other storage vendors out there. But VMware wrote it, so you can go in and Google this as well. But the cool thing was 2 petabytes of our customers' data was secured by blacklisting this feature. So we couldn't go in and do something wrong. So we secured our customers' data. Cool thing. Last one is a bit funny, but how many of you have the public IP to a storage environment? Usually somebody's laughing about it. But we actually do some ethical hacking. It's not 50 guys sitting back in headquarters and doing hacking stuff. It's an automatic process. But we have found out 100 customers are using public. I can go into the system and see 500 terabytes of data. So we call these customers and say, hey guys, maybe you should change this IP thing because I can see your data. Oh, I didn't know it. So these are just small examples. But this comes out to a big knowledge of our customers' environment. So we have a lot of uptime. We mentioned this. We have 9 out of 10 support cases are auto-closed. It's a way of us going out to you before you know you got an error. So 9 out of 10 times we know you have an error before you do. And we actually send a solution to you. Go into vCenter, do this, and you get fix the problem.
Can I just ask, do we go to 1:45 or do we go to the top of the hour?
Can't remember.
I think it's a 45-minute session, so.
That's why I need to speed up.
Yeah.
So whenever you call support, you get level 3 free support guides. This is our license. We don't have any license. We have a license, but we don't charge for it. So whatever feature we deliver, either on our storage environment for your switches or for a VMware host server or for whatever we do, you get that included in the package, in the support package. Great stuff on Veeam plugins, vRealize and stuff. You get it. Just download it, do it. The second thing is, I mentioned this. All our licenses, flat support. It's really easy to do, a long-term relationship with us. So with that.
Actually, I'm going to change things a little. Robert, I don't know if you all know Robert. He's a very well-known guy around here. He could be anywhere right now. He chose to be with us. We appreciate it. So I think we should give the last time to you. If there's time for demo after that, great. If not, please come to our booth. I'll be happy to show you a live demo of the application DNA from SQL Server, Oracle, whatever. It's a cool demo. If we don't have time to get to it now, I'd be happy to show it to you. Over to you, sir.
I can hurry up. I can do it really fast. So if you just prompt to pay attention. So, well, let's take that V1. We'll go really fast about this. Why are we talking vVols? The reason we're talking vVols is because all the stuff that I go out and talk about has nothing to do with storage. It has nothing to do with hardware. I don't care about it. Sorry about it. I want everything in software. And why do I want it in software? Because then I'm able to use it in a different way. I'm not tied into a specific component. I can do everything automatically. I can do automation. And when we talk about our software-defined data center, the point of that is to have the underlying systems in software. So every time you have things in software, you can change it. And of course, one of the ways of doing that is to have an abstraction layer, for example, if you're running Nimble, to have that in front of Nimble. And the way we do that is by using vVols. What we're trying to do is to get rid of this use case. This could be me. In my old company, every time I needed storage, I went down to the storage administrator and said, I want some storage. And he was like, yeah, what do you want? I want the fastest storage ever. And I never got it. Not a single time. I don't know if you ever tried that. But the storage guy did his best work, and he gave me a LUN bucket, whatever you want to call it, where I could put my VMs in. The problem is that we were 5, 6 VMware admins, and I knew that LUN was really fast on day one. My colleagues didn't know it. So after a couple of months, they probably vMotioned that application away like 10 times. Nobody locked the SLA from that LUN to the application. So we suddenly had a problem with, 5 minutes left, yes. We had a problem with aligning the SLA to the application. And that's what we're trying to do with vVol. We're trying to get rid of this. We're trying to tie in the performance metrics, the availability, the SLA to your application. And I don't know your applications, I know your virtual machine, so that's what we have to tie it into. So how do we do that? It's really simple. In vSphere 6.0, that's what's required to use vVol. You get a VASA provider. And a VASA provider in Nimble terms is the Nimble hardware box. You just correct me if
it's in the OS.
Silly. So what that VASA provider does, it enables us to, from the vSphere environment, to talk directly to the Nimble system, the storage system, and tell the storage system what to do. Instead of sending commands down using your normal communication path, then we do it using API. You can still connect exactly the same way as you do today. iSCSI, Fibre Channel, Ethernet, whatever. We don't care about that. But you use this basic provider to do everything. As a storage administrator, you can sit down here and say, yes, I want to give my VMware administrators the ability to do deduplication, replication, but encryption, no, hell no. I won't allow them to do that. And as the VMware administrator, I can sit up here and I can create policies based on the capabilities that the storage administrator gives to me, and I can assign them to every VM. So I can create a policy that says this is production. And every time I deploy a new virtual machine, I give it the policy production, and these features that's aligned to that policy gets attached to the VM. And when I delete it, it disappears. That's what it's all about. That is aligning those two. Oh, and that's the slide you put in. Sprite. I was like, what the hell? That doesn't look like any of my slides.
It's a geeky view of what you just described, showing that the boss provider for us is in the storage system, where with other guys it's somewhere else. And you,
Proxy server
yes.
outside of the environment.
I was warned, but
And then what about noisy neighbors? No, I didn't. I won't answer that.
yeah. So how does it work? Really simple. So just kind of hands-on. I actually set this up yesterday in my new vSphere 6.5 environment, and all I did was I went into the Nimble VMware integration, put in the host name of my vCenter server, username and password, checked web client, and checked VASA provider, and press next. And that's all I had to do from Nimble's point of view. It set up the VASA provider. That's a lot of certificates and everything. It did that. Then I went into volumes, and I created a new folder, because you need to have some kind of way to manage all the volumes that get created. And in Nimble terms, you do that in a folder. So I just choose managed by this, using virtual volumes, and managed by this vCenter, and I gave it some resources, and I pressed next. Then I went into vSphere, set new data store, exactly as you know it, pressed vVol, gave it a name, and said OK. And now I suddenly had a new log. It looks exactly like what you had before. Then I went in and said I want a new storage policy, gave it a name. In 6.5 you have some common services. So for example, I didn't want encryption from Nimble. I want to use encryption in vSphere, new vSphere 6.5 feature. So I can choose features that's agnostic, that I can choose across different environments. But I could just set that, I just wanted to show that. But other than that, I went in and I said I want to have the rules from the Nimble storage. And here I want to have some kind of snapshot policy. And as a VMware administrator, I could suddenly go in and say, I want to have snapshots every day of the week. I want to retain 24 snapshots, and I want to take them once every hour. And I could do that as a VMware administrator. I didn't have to go down to the storage administrator and say, can you please do that, and get a no, we don't do that. So I could set up the way I wanted it to. Press next, you can see which kind of data stores does have these capabilities. And finish. And after that, it was all about going into the VM and selecting on the disk level the VMUG vVol policy that I just created. And a couple of hours after that, going into Nimble again, selecting the VMDK files. Each of these are now a volume.
Yes, we all want a volume.
And if I go in and press on that one, I can see it's taking snapshots for me. So suddenly I can control, as a VMware administrator in software, I can control what I had to go down and ask the storage administrator to do before. And I can do this on every disk, on every VM. So I can have some VMs that's being replicated, I can have some VMs that's being snapshots, I can do it exactly the way I want it to. I don't have to put everything in a LUN and say, I hope this VM stays here and it always stays replicated. I can suddenly attach this layer to it. That was the fastest vVol presentation I ever done.
I was just going to mention that the cool thing about this is it wasn't a lot of work for us to do the vVol part, because we had a plugin for years now for vCenter that allows you to do all of the storage administration from vCenter. So all we had to do was put the vVol hooks in there. So the framework has been there for years. It wasn't really that much work for us to build in the vVol part. So that's why it's such a complete implementation, I'd say.
Yeah.
Is there any performance hits running vVols?
From the
From
storage-
vSphere, just maybe I can say that.
Yeah.
From vSphere, all we do is to tell the storage system to do anything. We don't put data back and forth using the data path. We use the API instead. So
The only time we've ever seen any kind of performance issues that we would say are general to VMware has to do with snapshotting. And that's mainly because when you have a lot of busy VMs on the same VMDK and you want to do a VMware synchronized snapshot, the SCSI queuing mechanism into the virtual disk was not super elegant, so it could cause timing out, unable to quiesce a busy VM. Now we don't have that problem anymore because we have a one-to-one between the application, the VMDK, and that's what we're snapping, and the LON on the back end. So that's actually going to be faster. From a general processing performance standpoint, it's all cosmetic, because to us it's just block storage. Did that answer your question?
Yeah, fine.
So again, it doesn't cost you anything. You have it in your license. You just have to run vSphere 6.0, and I'm guessing that the last 200 versions of Nimble OS has this feature as well.
Correct.
So
Can we ask you who set up your environment, your demo environment?
I think I did it.
He did the whole thing himself, the storage array, everything himself. All we did was run the box. So he did all
I
this
am not a storage administrator. Believe me, ask any of my colleagues. They can do like this every time I go out to the server room. Like, oh no, something breaks in a minute. So, but again, it is really simple. You can do it in software, and you don't have to run vVol on everything. If it makes sense for you to run vVol, do it. Put everything in software instead. If you want to change the storage policy, for example, here, if I suddenly wanted a snapshot, change the snapshot schedule, I go into one profile and I change that, and all the VMs that has this policy attached to them gets changed. It's quite simple. So there's no reason not to do it. And you're all running vSphere 6, yes?
No.
6.5? Oh, that's good.
No.
How many have thought that migration path might be an issue, which is why they haven't considered vVols? If it's too much work, it's too difficult to get from what I have now to that, or what is your
as we talked about earlier, I'll put it back to you guys. So it's again, we are just talking to you guys using API.
Yeah.
So it is a storage feature to how you handle the migration. So
It's not a lot of extra work or admin or anything like that, so don't be scared of it.
And just to understand, one thing it doesn't rule out, because you just make this folder for vVols and you still do your LONs to
Exactly.
yeah. In my demo environment, I have a normal LON as well, because that makes sense to have my ISO images, whatever, and that. So
That's a really good point, Morten, because you could always say, well, why not use vVols for all your new stuff, right? Then there is no migration path, and eventually move stuff into the new framework. So there's always a good reason to use them.
yeah, one place where I probably wouldn't use it today is VDI, because you get a new LON every time, and we do have a max limit on how many LONs you can have. So you kind of provision 10,000 VMs, you might have a problem. And there's a LON for the VMDK file, for the swap file, and for the VMX file. So there's 3 LONs for every VM, so you can kind of see it going on. I would probably just use a normal LON volume, whatever that.
I would agree.
So, cool.
Any questions? No demo. I think they're going to throw us out of here. So
Log into the demo environment.
Okay, well, if anyone wants me to start until they kick us out, I'd be happy to show you some cool stuff. Thanks, Robert. That was great and fast, and
Really fast.
it tells a fast story because it's a fast platform. I can say that. So we have our portal called InfoSite, which is basically driven. Peter talked a lot about it. It's 40 million data points per array that get sent to our support group, and they get mined in a massive Vertica instance. I think it's the biggest instance of Vertica in the US. In the world probably. Has all the data points from every array we've ever shipped from day one. That was traditionally used to drive auto support. One fine day, the data scientist said, we have all this data, why not create a trend analysis portal? That's InfoSite. I thought I'll start with VM Vision because this is a VMUG. The big things we're trying to identify are the bully VMs, the noisy neighbors. There's lots of names for them, but for you that means applications generating a lot of I/O and applications that might have, or VMs that have high latency. First thing we see right now, top VMs by I/O, top VMs by latency. Everything in InfoSight is pretty much a hyperlink, and it's pretty easy to find your way around. But if we just go into this crazy VM, and it's a great example because I've already talked to the customer about it, and he laughs and says, don't even look at that VM because I do crazy shit on it, but it makes a good demo. We're on a wireless connection, so if it takes time to load data, I apologize for that. So what this is going to do is it's going to give us a breakdown of the latency by factor, and it does a slice up between host, network, and storage. So if we go to this massive peak over here, we can see that at that particular point in time, 82 milliseconds of it was from host, and then we can see the split in the network and the storage. And then we can correlate that to the load on the host down below, CPU utilization, memory utilization. And the idea here is we can see, well, if we have a high latency situation on a VM, is that because the host is overwhelmed, the CPU is underwater, whatever, we can make that correlation. This is kind of an outlier, so it didn't really make for a good case. Another thing we could do is we could see what's the activity on our hosts. And the look and feel of this was supposed to be as close to vCenter as possible, so the vCenter admins would feel comfortable here. And I think we did a pretty good job of that. This is all the hosts, and again, it's hyperlinked, so you can go in, click on a host, and you can get a breakdown of memory, CPU, swap, all that stuff for the individual hosts. The data store tree map basically shows us which of our data stores have the highest latency. So the redder it is, the higher the latency. So we'll go to a nice red one, and we'll say, that's pretty high latency. It's all hyperlink, so we'll just click on it. Takes us into the data store and gives us that latency breakdown. And there's several different views here. So you can go into the data store view, the virtual disk view, the VM, the host, and it's linked all together. And then we get a nice split on performance on the data store for latency, IOPS, and throughput. And then we can split that up between read and write. So pretty powerful stuff. And the thing to keep in mind is this is a block storage device that is looking all the way up the stack to a VM. So we're basically going into a block LUN and saying we know which blocks belong to which VM, and we can give you these performance analytics on that VM without having any agents or anything external installed in between. We're just using native ESX performance streaming and our Nimble plugin that we provide as part of the OS, not for free, but as part of the list cost. So anyway, pretty powerful stuff. That's kind of the core VM vision. I don't want to really go too crazy with it because there's another cool part of this I wanted to show you. This goes along with another thing that Peter was really in on, in application DNA, really being application-centric storage, so we understand the DNA of the application. Like you showed that great slide for Oracle, we know the attributes of it, what it needs, same thing for SQL Server. I thought I'd go in and show you a sample of a query that we can run that goes all the way up to the SQL Server layer from the storage system, again with nothing in between that you need to install or worry about. So we group things in, or LUNs, in what's called a pool. A pool is a function of scale out, because you can scale up to 4 Nimble arrays together in a cluster, and then you decide how you want to distribute the data. And you do that by creating a LUN or a volume that goes in a pool. If you don't want to do that, you get what's called a default pool, or if you have a single array cluster, because every array is a cluster when you install it, even if it's a standalone array, and it gets a default pool. So here we see that we'll go to, which I know is this customer's production system, and by the way, this customer has given us explicit permission to show his environment in this kind of setting. We don't just go show our customers to anybody, because that's not really a cool thing to do. I want to show some database specific stuff, and I would like to show SQL Server this time because I know he has loads and loads and loads of it. And then we can pick what we want to see. Do we want to see IOPS, throughput, latency? I kind of want to know what the block size heat map looks like. What size block I/O are we doing during different parts of the day? So we'll do, okay, what's our average read size? And then we'll do write size. And then we'll run the query. If I hit the button. And then basically it's going to break down hourly what the SQL Server in general is doing as far as block size reads and writes. And it's nice to see if they're somewhat close. And I think you'll notice that we're doing, during a certain part of the day, we're doing mostly 8 to 16K block reads and writes, actually, which is good. I'm gonna break your phone. I think this is why Robert gave up live demos. Okay, so yeah, so we can see that the darker it is, that means it's the busier time for that block size. You can see we have a timestamp down below. So if we, in InfoSight, this is another good thing to notice. Every time you hold your mouse over a data point, you get the absolute values. So if we go up here to this big black stripe where we're doing the most big block IO, probably good if I lift it up, we can see that during that time, 65.4% of our operations were 8 to 16K block size. Pretty cool to know. And lo and behold, it was exactly the same, not as high on the write operation, but it was the same block size, and that's the majority of them. So the whole idea with InfoSight is being able to correlate. If we wanted to do something a little more generic, we could eliminate those fields and do maybe IOPS and throughput, because we like to correlate those things as well. Run a new query. And again, this is going into a specific application type. And remember, Nimble is block storage. The only thing we focus on is a block. So if we have a block that's randomly read, on a hybrid system, we're going to cache it. Yes, thank you. And if it's not randomly read, it's going to be served from disk, whether it be SSD or spinning disk. But the idea is we have the block in mind. We don't have the LUN in mind. We don't have the application in mind. So here we have our IOPS split, read write, and then the same with throughput by time of day. So a lot of this stuff is available through the GUI itself. The thing about the statistics on the GUI versus InfoSight is long-term trend analysis based on data points from installation day to now, whereas the stuff you see in the GUI is a little more real-time. You can go back to 90 days, but this allows you to go back to the beginning of time if you so choose.
Steve?
Yes?
The keynote starts in, the closing keynote starts in 2 minutes.
Okay.
So, just
Well, anyway, I think that's a
Thank you
good.
for your time.
If you want to see more of this, we can do a WebEx, whatever. There's loads here. I'd love to show it to you.